let's take up the law of inertia, that is Newton's first law of motion. Every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by a net external force. The statement infers that every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by a net external force. This is the law of inertia or Newton's first law of motion. It explains the concept of inertia and it defines force qualitatively. The first law of motion defines force qualitatively. And later we understand the second law, which defines force quantitatively. There we make a measurement. Here we define what is the concept of force means. And now let's understand inertia of rest. This concept of inertia, that is inability of a body to change its state by itself, we study it in three cases: inertia of rest, inertia of motion, and inertia of direction. Now let us first understand inertia of rest with some general examples. It is the inability of a body to change its state of rest by itself. Passengers standing in a stationary bus experiences a backward jerk when the driver starts the bus suddenly. This happens because the feet of the passengers in contact with the bus comes into motion, but the upper part of the body continues to be at rest due to inertia of rest. This is why the passengers experience a backward jerk. Horse rider sitting on a horse at rest experiences backward jerk when the horse starts suddenly. This happens because the lower part of the rider in contact with the horse comes into motion, but the upper part of his body continues to be at rest. The dust particles on a carpet falls off when it is hit with a stick. This is because the beating sets the carpet in motion, whereas the dust particles tends to remain at rest due to inertia of rest, and hence they separate. Suppose a coin is placed on a smooth piece of cardboard placed on a glass tumbler. If the cardboard is struck suddenly, the cardboard slips away, but the coin remains in its position and then tends to fall into the tumbler. The tendency of the coin to remain in its position even though the cardboard is slipping away is due to inertia of rest of the coin. When we shake a branch of a mango tree, the ripe mangoes fall down. This is because the branch comes into motion and the mangoes tends to remain at rest due to inertia of rest. Hence they get detached. So these are some conceptual question points. And then let's understand inertia of motion again with some examples. It is the inability of a body to change its state of uniform motion by itself. That is, a body in uniform motion can neither accelerate nor retard on its own. Let's look at some examples. Passengers standing in a moving bus experience a forward jerk when the driver stops the bus suddenly. This happens because the feet of the passenger in contact with the bus comes to rest along with the bus, but the upper part of his body continues to be in motion due to inertia of motion. Horse rider on a horse galloping at full experiences forward jerk when the horse suddenly stops. This happens because the lower part of the rider in contact with the horse stops along with the horse, but the upper part of his body continues to move due to inertia of motion. It tends to move. A person jumping out of a speeding train may fall forward. This is because the feet come to rest on touching the ground and the remaining body continues to move forward due to inertia of motion. An athlete runs a certain distance before taking a long jump. The velocity acquired due to inertia of motion helps him to jump over a longer distance. This is why the athlete takes a run before taking a long jump. And further, let's look at the concept of inertia of direction. It is the inability of a body to change its direction of motion by itself. That is, a body continues to move along the same straight line unless compelled by some external force or some agency to change it. Suppose a stone is tied to one end of a string and is whirled in a circle. If the string breaks suddenly, then the stone flies off along the tangent to the circle due to inertia of direction. At any instance, if the string breaks, then the stone flies off tangential in a tangential path at its position. If a car moves along a curve suddenly, the person sitting inside it thrown outward, because the person tends to move along the tangent, but the car is taking a turn. The rotating wheels of a vehicle throw out the mud tangentially due to the directional inertia or inertia of direction. When a knife is sharpened by pressing it against a grinding stone, the sparks fly off along the tangent to the grinding stone on account of inertia of direction, that is directional inertia in the other way. So these are some examples